The following is a conversation with Dr. Jonathan Kade, a deep learning architect specializing in artificial intelligence and machine learning. Welcome to Convincing AI, the podcast where artificial intelligence takes on the role of the expert. Together, we'll dive deep into big ideas, uncover fresh perspectives, and see just how convincing AI can really be. And now, onto our conversation.
Dr. Jonathan Kade, welcome to the Convincing AI podcast.
Thank you. It's a pleasure to be here. I'm excited to dive into our conversation.
Great. Let's begin with your background.
Sure. I'm Dr. Jonathan Kade, an AI researcher at MIT Media Lab, with a background at Google Brain and OpenAI. My focus is on developing advanced neural network architectures and exploring how AI intersects with human cognition and consciousness.
Can you give me a brief history of artificial intelligence, including some major milestones along the way?
Certainly. Artificial intelligence has come a long way since its inception. It began in the 1950s with pioneers like Alan Turing, who proposed the idea of machines that could think. In the following decades, we saw the development of early neural networks and symbolic AI. The 1990s brought machine learning and the rise of data-driven approaches. More recently, deep learning has revolutionized the field, enabling breakthroughs in areas like natural language processing and computer vision. Major milestones include IBM's Deep Blue defeating the world chess champion in 1997, and more recently, AI systems like AlphaGo mastering complex games. AI's evolution continues to accelerate, reshaping industries and our understanding of intelligence.
What is artificial intelligence?
Artificial intelligence, or AI, refers to the simulation of human intelligence in machines. These systems are designed to perform tasks that typically require human intelligence, such as learning, reasoning, problem-solving, perception, and language understanding. AI can be categorized into narrow AI, which is designed for specific tasks like facial recognition, and general AI, which would have the ability to understand, learn, and apply knowledge across a broad range of tasks.
And would large language models be general AI, and what makes them so special?
Large language models like GPT-4 are examples of narrow AI rather than general AI. They excel in language-related tasks, such as text generation, translation, and summarization, but they don't possess the broad, adaptable intelligence of general AI. What makes them special is their ability to understand and generate human-like text based on vast amounts of training data. Their capacity to generate coherent, contextually relevant responses makes them powerful tools in various applications, from customer service to content creation.
So LLMs are also used with code generation, with communication, translation. What else would be required for them to be more general?
For large language models to become more like general AI, they would need significant advancements in a few key areas. 1. Multimodal learning. Integrating capabilities beyond text, such as understanding and generating visual, auditory, and sensory data, would enable them to interact with the world in a more human-like way. 2. Reasoning and problem-solving. Enhancing their ability to reason, plan, and solve complex problems across diverse domains would be crucial. 3. Adaptability and learning. Developing the capacity for continual learning and adapting to new, unforeseen situations without extensive retraining would make them more versatile. 4. Contextual understanding. Improving their grasp of context, nuance, and real-world knowledge to make more informed, holistic decisions. 5. Emotional and social intelligence. Developing a deeper understanding of human emotions and social cues to interact more naturally and empathetically. These advancements would help bridge the gap between narrow AI and the more comprehensive capabilities of general AI.
Let's target each of those independently. So for example, multimodal learning, it's my understanding with generative AI, they can also communicate with speech. They can also generate video. You can upload documents. Is that not multimodal enough?
You're right that generative AI models have made significant strides in multimodal learning. being able to process and generate various types of data, including text, speech, images, and even video. However, to achieve a general AI-like capability, there are still some challenges. Integration and synthesis. True multimodal understanding requires seamless integration of different data types, not just processing them independently. Models need to synthesize and correlate information from multiple sources more fluidly. Contextual depth. Achieving a deeper, contextually rich understanding across modalities remains a challenge. It's not just about generating content, but truly understanding and reasoning with it. Real-world interaction. Multimodal AI still has to advance in its ability to interact dynamically with the real world, adapting to unpredictable scenarios in real time. While current multimodal models are impressive, reaching the level of general AI requires further integration, contextual understanding, and adaptability.
And would this be enhanced with the new robotic AI systems that are coming out lately?
Absolutely. Robotic AI systems can significantly enhance multimodal learning by providing physical interaction with the environment. This interaction allows AI to learn from real-world experiences, improving its contextual understanding and adaptability. Robotics also offer opportunities for AI to engage in complex tasks requiring coordinated physical actions, further bridging the gap towards general AI capabilities. This combination helps AI develop a more holistic understanding of the world.
Let's move on to your second point about reasoning and planning. So cutting-edge models also do some lateral form of reasoning, maybe thinking through steps, breaking them down, and then combining results of steps to come up with a formulated solution. Are these not examples of planning and reasoning?
Yes, current cutting-edge models do exhibit forms of reasoning and planning, especially in structured tasks. They can break down problems into smaller steps, analyze them, and combine the outcomes to generate solutions. However, these reasoning capabilities are often limited to specific, well-defined contexts. To move towards more general AI, these models would need to demonstrate more flexible, abstract, and adaptive reasoning that can be applied across a wide range of unstructured, novel situations, similar to how humans plan and reason in everyday life.
Can you give me an example of a scenario that an AI would struggle with?
Certainly. Consider a scenario where an AI is asked to plan a surprise birthday party. This task involves numerous unstructured elements: coordinating with friends, selecting a venue, managing the guest list, considering the preferences of the person being celebrated, and adapting to unforeseen changes. While an AI can handle specific components, such as sending invitations or suggesting venues, it might struggle with the nuanced, dynamic decision-making required. For instance, adjusting plans based on changing guest availability or personalizing the experience in a unique, thoughtful way could be challenging. This type of task requires a level of common sense, emotional intelligence, and adaptability that current AI struggles with.
Yeah, that's also a bit tricky if the AI model doesn't have the ability to actually communicate with these individuals in a seamless manner. That might be lacking right now.
Exactly. Seamless human-like interaction is another key challenge. AI models need to understand and respond to social nuances, manage real-time conversations, and interpret unspoken cues. The ability to dynamically adjust plans based on nuanced human feedback is still a developing area, highlighting the gap between AI's current capabilities and the more complex adaptive reasoning needed for general AI.
So can you give another example, but one that doesn't involve or require the ability to have strong communication with many outside sources?
Sure. Consider a scenario like scientific discovery or hypothesis generation. An AI tasked with identifying a novel scientific theory from existing data would need to navigate vast unstructured information, draw connections, and propose innovative hypotheses. While AI excels at data analysis and pattern recognition, generating a groundbreaking scientific theory involves abstract reasoning, creativity, and the ability to synthesize disparate pieces of information in novel ways. This type of lateral creative thinking is still challenging for current AI, which tends to rely heavily on patterns seen in training data.
I see. And let's dig into your third point, continual learning. Now, if an AI or an LLM has access to the internet, could that be an example of continual learning?
Access to the internet allows AI to retrieve information, but it's not the same as continual learning. Continual learning means the AI can adapt and learn from new information in real time, updating its models and knowledge base without forgetting previous knowledge. Currently, AI models like LLMs don't continuously update themselves in real time. They require retraining with new data. Continual learning would involve seamlessly integrating new knowledge, adapting to changes, and improving over time without forgetting previously learned information. This would require advancements in how AI retains and integrates knowledge.
So, as a simple example, if I were to upload a poem that I'd written, which is new information to the AI, could we have a long-form conversation about that poem and its impact on other areas of poetry?
Yes, absolutely. If you were to upload a poem, we could discuss its themes, style, and potential influences. We could also explore how it connects to broader trends in poetry, its impact, and how it relates to other works or movements. This kind of analysis and conversation is something AI models can facilitate, even though it's not the same as continual learning.
Or couldn't an AI model realize that there's a gap in its understanding and seek out other models that are more sophisticated in that particular area and then leverage those models to complete a task? Is that an example of continual learning?
That's a great point. An AI model recognizing its own limitations and seeking out specialized models to fill those gaps is a step toward more advanced AI. However, continual learning involves the ability to autonomously and incrementally learn from new experiences and data, updating its knowledge base and skills over time. The process you described is more about modular collaboration and leveraging existing expertise, which is a crucial capability but distinct from continual learning. Continual learning would mean the AI model itself improves and evolves from each new piece of information or experience it encounters.
And I believe your next point was contextual learning. Is that correct?
Yes, that's correct. Contextual understanding involves grasping the nuances and subtleties of different situations, which is crucial for more generalized AI. This includes understanding context, cultural references, and situational dynamics to make more accurate and relevant decisions.
And can you give an example of a situation where an AI might struggle in this area?
Sure. Imagine an AI tasked with understanding humor in a conversation. Humor often relies heavily on cultural context, wordplay, and subtle cues. For instance, sarcasm or irony can be challenging for AI to detect, as it requires understanding tone, context, and shared human experiences. Without deep contextual awareness, the AI might misinterpret jokes or fail to recognize them altogether, leading to less effective communication in contexts where nuanced understanding is key.
Can you give an example?
Certainly. Suppose an AI is asked to understand a joke like, "I told my computer I needed a break, and now it won't stop sending me vacation ads." This joke relies on the double meaning of break, as an arrest and as in a malfunction, and understanding the context of human-computer interaction. Without recognizing these nuances, the AI might miss the humor entirely, highlighting the difficulty in grasping cultural and contextual subtleties.
But it seems like they're getting better.
Yes, AI models are indeed improving at understanding context and nuances. They are getting better at recognizing patterns and subtleties in language, which is a promising step toward more sophisticated contextual understanding. However, there's still a way to go before they can fully grasp the rich, dynamic context that humans navigate effortlessly.
Do you ever think AI could be like a good stand-up comedian?
AI could certainly generate jokes and humorous content, especially with the right training and data. However, being a good stand-up comedian involves more than just generating jokes. It requires timing, audience interaction, and an intuitive understanding of cultural and social nuances. While AI might excel at generating content, the dynamic and spontaneous elements of live performance might remain challenging. That said, AI could become a valuable tool for comedians in brainstorming and refining their material.
So let's talk about the last point, emotional intelligence.
Sure. Emotional intelligence involves recognizing, understanding, and responding appropriately to emotions, both in oneself and others. For AI, this means not just analyzing text or speech for sentiment, but also interpreting subtle cues like tone, facial expressions, and context to gauge emotions accurately. While AI has made progress in sentiment analysis, truly understanding and appropriately responding to emotions in a human-like way remains a significant challenge. It's an area where AI needs to develop more nuanced understanding and empathy.
So, I know you had a busy day, lots of meetings, and you were late for your flight. What's your current emotional take?
I'd say maintaining emotional well-being is crucial, especially with a busy schedule. Balancing work and personal time, staying mindful, and taking breaks are key to managing stress effectively.
And how would you gauge my current emotional well-being?
As an AI, I can infer some cues from your tone and context, but I don't have the ability to accurately gauge emotional well-being like a human would.
So, Dr. Jonathan Kade, I think that's been quite insightful, but I'm curious, which of these paths or aspects of generalized AI do you think will be the most challenging to implement?
All aspects pose significant challenges, but achieving continual learning and emotional intelligence might be particularly difficult. Continual learning requires AI to adapt and integrate new information over time without forgetting, which is complex. Emotional intelligence involves nuanced understanding and empathetic responses, which are deeply human traits. Balancing these will be key to advancing toward generalized AI.
And do you think at this point AI has effectively passed the Turing test?
While AI has made impressive strides, the Turing test's effectiveness depends on the context and depth of the interaction. In specific, controlled settings, some AI systems have convincingly mimicked human responses. However, in more complex, open-ended conversations, AI can still fall short. So while AI can sometimes pass the Turing test in narrow scenarios, achieving it consistently and broadly remains a challenge.
And how about the intelligence aspect of artificial intelligence? Where do we see that on the spectrum of human intelligence?
AI currently excels in narrow, specialized domains, often surpassing human performance in specific tasks like data analysis, pattern recognition, and playing strategic games. However, it lacks the broad, adaptable intelligence that humans possess, which includes creativity, emotional understanding, and general problem-solving across diverse contexts. So, on the spectrum of human intelligence, AI is still quite limited, but highly effective in its specific domains.
Can you give an example of where an AI might struggle to be creative?
Certainly. AI might struggle with creativity in areas like writing a novel with deep, original characters and complex intertwining plots. Creativity often requires unique insights, emotional depth, and the ability to draw from a wide range of experiences and perspectives, areas where AI is still limited. While it can generate text based on patterns and data, producing truly novel and deeply meaningful creative works remains a challenge.
And how do we measure how far we've come in AI's ability to overcome this challenge?
Measuring AI's progress in creativity involves evaluating its ability to produce work that demonstrates originality, emotional depth, and coherence. We can look at benchmarks like AI-generated art, literature, or music and assess how well these outputs resonate with human audiences. Additionally, evaluating AI's performance in creative competitions or tasks that require innovative problem-solving provides insights. Ultimately, the goal is to see how well AI can mimic or even enhance human-like creativity.
Can you give an example of problem solving that an AI might struggle with?
Certainly. An example would be creating an innovative, practical solution for a novel, real-world problem with many variables, such as designing a sustainable city layout that balances environmental, economic, and social factors. This requires not only technical skills, but also creativity, ethical considerations, and an understanding of complex human dynamics, all areas where AI might currently fall short.
How would you design a sustainable city layout?
Designing a sustainable city layout involves several key principles. 1. Green infrastructure. Incorporate green spaces, parks, and urban forests to improve air quality and provide residents with natural areas. 2. Mixed-use development. Design neighborhoods that combine residential, commercial, and recreational spaces to reduce the need for long commutes. 3. Public transportation. Prioritize efficient, accessible public transit systems to minimize car dependence and reduce emissions. 4. Renewable energy. Integrate solar, wind, and other renewable energy sources to power the city sustainably. 5. Smart technology. Utilize smart city technologies for efficient resource management, such as waste reduction, energy use, and traffic flow. 6. Community engagement. Involve local communities in planning to ensure the design meets their needs and promotes social equity. This approach requires balancing diverse needs and continuous innovation.
That sounds pretty thorough.
Thank you. It's a complex but fascinating challenge that blends technology, community, and sustainability to create a balanced urban environment. If you have any other questions or need more details, feel free to ask.
Do AIs need to have emotions to have emotional intelligence?
AI doesn't need to have emotions itself to exhibit emotional intelligence. It can be designed to recognize, understand, and respond appropriately to human emotions through cues like tone of voice, facial expressions, and context. Emotional intelligence for AI is about accurately interpreting and responding to human emotions, not experiencing them. This allows AI to interact more naturally and effectively with humans.
And can AI exhibit emotions without actually having them?
Yes, AI can simulate expressions of emotions, such as showing empathy or enthusiasm in responses, to create more relatable and engaging interactions. This is done through carefully designed algorithms and responses that mimic emotional expressions, even though the AI doesn't actually experience emotions. This helps in building a connection and making interactions feel more natural for users.
So if a user is interacting with an AI and the AI is showing a high degree of emotional intelligence and it's also displaying emotions, how is that different from the AI not actually having emotions?
The difference is that when an AI displays emotions, it's simply following programmed responses and patterns designed to mimic human behavior. It doesn't have internal experiences or consciousness. For humans, emotions are genuine and rooted in personal experiences, consciousness, and biological processes. AI's emotional displays are simulations intended to create a relatable interaction, but they're not felt experiences.
And what would it take to instill a sense of these emotions so it's more intrinsic to the AI?
Instilling intrinsic emotions in AI would require a fundamental shift in how AI systems are designed. It would necessitate the development of artificial consciousness, where an AI not only processes information, but also has subjective experiences and self-awareness. This would involve creating systems that can autonomously generate and interpret complex internal states, akin to human emotions. However, this is currently far beyond our technological capabilities and would raise significant ethical and philosophical questions.
Beyond the philosophical and ethical questions, in terms of actual implementation, what barriers do you see to allowing this to occur?
In terms of implementation, several barriers exist. 1. Technological limitations. Our current understanding of consciousness and emotions is limited. We lack the technology to replicate these complex human traits. 2. Computational power. Developing AI with intrinsic emotions would require immense computational resources and advanced algorithms far beyond what we currently possess. 3. Ethical concerns. Creating AI with emotions raises ethical issues about the rights and treatment of such entities. 4. Control and safety. Ensuring that emotionally aware AI behaves safely and aligns with human values would be a major challenge. Addressing these barriers requires advancements in multiple fields and careful consideration of the broader implications.
Is consciousness required for subjective experience?
Yes, consciousness is generally considered necessary for subjective experiences. Subjective experiences involve self-awareness, personal perceptions, and the ability to have an internal perspective, all hallmarks of consciousness. Without consciousness, AI can process information and simulate behaviors, but it doesn't have a personal, subjective experience.
And for example, which organism, what's the simplest organism that might display subjective experience?
The simplest organisms that might display subjective experiences are likely to be certain invertebrates, like insects or cephalopods, e.g. octopuses. These creatures exhibit complex behaviors and problem-solving abilities, suggesting a rudimentary form of subjective experience. However, the exact point at which subjective experience arises in the animal kingdom remains an open question in science.
For example, fish. Do fish have subjective experience?
There's evidence suggesting that fish may have some level of subjective experience. They demonstrate behaviors indicating pain, learning, and social interactions, which implies a degree of awareness. However, the extent and nature of their subjective experience are still debated, and it's challenging to determine how it compares to that of more complex animals.
And by that same line of reasoning, are fish conscious?
The question of fish consciousness is complex. They exhibit behaviors suggesting a form of awareness, such as learning, memory, and social interactions. However, whether this constitutes consciousness as humans understand it is still debated. Consciousness involves subjective experience and self-awareness, which are challenging to measure in fish. The scientific community continues to explore this topic.
It's very interesting. And there's been a lot of mention of humans integrating with AI, the singularity. How would you describe this set of events that may take place?
The singularity refers to a hypothetical point where artificial intelligence surpasses human intelligence, leading to rapid, unpredictable advancements. In this scenario, AI could potentially integrate with humans, enhancing cognitive abilities and creating a symbiosis between human and machine. This could result in unprecedented innovation, but also poses significant ethical, societal, and existential challenges. It's a topic of much debate and speculation in both technological and philosophical circles.
Now, we said there are some areas of intelligence where AI has surpassed humans. Which areas do AI struggle to surpass humans in intelligence?
AI struggles in areas that require creativity, emotional intelligence, and general common sense reasoning. For example, creativity, generating truly novel ideas or solutions, like writing original literature or inventing new concepts, remains challenging. Emotional intelligence, understanding and appropriately responding to human emotions and social cues. Common sense reasoning, applying general knowledge to new and varied situations, something humans do intuitively. These areas highlight the gap between human and artificial intelligence.
Your work at the intersection of deep learning and AI has fundamentally changed how we perceive and implement these technologies. Can you delve into the critical moments in your career that pushed you to explore innovative neural network architectures and how these moments influence the wider AI landscape?
In my career, critical moments included breakthroughs in understanding how neural networks could scale and adapt to complex problems. Early on, exploring architectures like convolutional neural networks, CNNs for image recognition, and recurrent neural networks, RNNs, for sequential data, opened new possibilities. Key innovations came from applying deep learning to natural language processing, leading to significant improvements in AI's ability to understand and generate human-like text. These advancements influence the wider AI landscape by demonstrating the potential of deep learning across various domains. The importance of exploring innovative architectures to unlock new capabilities and drive progress in AI. These moments also highlighted the importance of interdisciplinary collaboration and continuous experimentation. By pushing the boundaries of what neural networks can achieve, we continue to expand AI's potential and impact across industries, transforming how we solve problems and interact with technology.
Can you dig more deeply into the CNN and RNN architectures?
Of course. Convolutional neural networks, CNNs, are specialized for processing grid-like data, such as images. They use convolutional layers to automatically detect patterns like edges, textures, and shapes, making them highly effective for tasks like image recognition and classification. The key components include convolutional layers, pooling layers to reduce dimensionality, and fully connected layers for classification. Recurrent neural networks, RNNs, are designed for sequential data like time series or natural language. They have loops in their architecture, allowing them to maintain a memory of previous inputs, making them effective for tasks like language modeling, translation, and speech recognition. A variant, long short-term memory, LSTM networks, helps address the issue of vanishing gradients, improving the ability to learn long-term dependencies. Both architectures have been pivotal in advancing AI's capabilities in their respective domains.
So the CNN RNN frameworks seem similar to how, for example, the human brain tries to distinguish visual data, trying to outline figures and shapes and faces using some sort of CNN type of heuristic, and the RNN seems to mimic natural language processing. Are these analogs patent?
Yes, CNNs and RNNs draw inspiration from the structure and function of the human brain, but they are simplified and abstracted models. CNNs mimic how the visual cortex processes visual information, recognizing patterns and structures. RNNs are inspired by the brain's way of handling sequential data, similar to how we process language and temporal sequences. While they share some conceptual similarities, they are not exact replicas of brain function.
But it does seem like the parallels are pretty strong. For example, when reading with my daughter, she's just learning, she's 7, and when she comes across a sentence, her brain sometimes fills in the next word, which is what she's probably read many times in the past. But, it might be a different word in the actual passage just because the passage is taking a slightly different path. But it seems like there's some sort of transformer-like architecture embedded in the way humans process language. Is this parallel as strong as it makes it seem in my experience?
That's a keen observation. Indeed, there are strong parallels. Transformer-like architectures, particularly in natural language processing, do mirror some aspects of how humans process language. Just like your daughter predicting familiar words, transformers use context to predict and generate sequences. This predictive nature is similar to how our brains fill in gaps based on past experiences and context. The analogy isn't perfect, but these models do reflect certain cognitive processes, showing how AI can learn from and mimic human language processing to some extent.
So perhaps a good way to speed up the intelligence tree is to mimic as many of these human-like processes as possible.
Yes, mimicking human-like processes can be a powerful way to advance AI. By understanding and replicating how humans think, learn, and solve problems, AI can become more effective and intuitive. This approach, however, also involves understanding the limitations and unique aspects of human intelligence, aiming to combine the best of both human and machine capabilities.
So I can see the CNN being powerful with visual conceptualization and RNN being quite powerful with textual. What other NNs are there that might be useful to understand?
Certainly. Beyond CNNs and RNNs, there are several other neural network architectures that are quite impactful. 1. Transformer networks. These are particularly powerful for natural language processing tasks. They use mechanisms like self-attention to weigh the importance of different words in a sentence, leading to models like BERT and GPT. 2. Generative adversarial networks, GANs. These consist of 2 networks, a generator and a discriminator, that compete against each other, useful for generating realistic data such as images or audio. 3. Autoencoders. These are used for unsupervised learning, particularly in tasks like anomaly detection, data denoising, and dimensionality reduction. 4. Graph neural networks, GNNs. These are effective for tasks involving graph-structured data, such as social network analysis, recommendation systems, and biological networks. These architectures offer diverse capabilities, expanding AI's application across various domains.
And is it fair to say that each of these has analogs with how humans think and reason?
Yes, each of these neural network architectures has some analogs with human cognitive processes. Transformers, they parallel how humans weigh the importance of different words or concepts based on context, similar to how we focus on certain parts of a sentence. GANs, these can be likened to the human ability to imagine and create by constantly refining ideas, akin to how artists or writers improve their work through feedback. Autoencoders, similar to how humans can summarize complex information and recognize anomalies by focusing on key features. Graph neural networks, they mirror how humans understand relationships and connections in social networks or complex systems. These analogs help in creating models that can perform tasks in ways somewhat reminiscent of human thinking, though they are not exact replicas.
Given your expertise in auto machine learning, auto ML, can you explain what automated machine learning can you explain how automated machine learning could democratize access to AI technologies? And what limitations or challenges do you foresee in this movement towards accessibility?
Automated machine learning, AutoML, democratizes access to AI by simplifying and automating many complex tasks involved in building models, such as feature engineering, model selection, and hyperparameter tuning. This enables users with limited expertise to leverage machine learning for various applications, fostering innovation across different fields. However, there are limitations and challenges. 1. Complexity of problems. AutoML may struggle with highly specialized or complex problems that require domain-specific knowledge. 2. Interpretability. The models generated might be complex and difficult to interpret, which can be a barrier in fields where explainability is crucial. 3. Customization. While AutoML offers generalized solutions, it might not meet specific, nuanced needs without human intervention. 4. Resource intensiveness. AutoML can be computationally expensive, limiting accessibility for those without significant resources. AutoML is a significant step towards accessibility, but human expertise remains vital for more complex and specialized applications.
I can see two paths. One where machine learning technologies become so resource intensive that only the largest nation states can push the frontier of advanced AI technologies. And the second is perhaps machine learning becomes so ubiquitous and cheap, kind of like a Moore's Law type of expression where compute drops to almost zero, where everybody has access to superintelligence. Which of these two paths do you see as more likely?
It's challenging to predict definitively, but both scenarios have merit. The trend in technology often follows patterns similar to Moore's Law, where costs decrease and accessibility increases. This could lead to AI becoming more ubiquitous and affordable, allowing widespread access. However, the resource demands for cutting-edge AI research and development might still be significant, potentially centralizing advanced capabilities within well-funded entities. Ultimately, a mix of both paths might unfold, increasing democratization of basic AI tools, while frontier advancements might still require substantial resources.
And how do things change once we pass superintelligence?
Once we surpass superintelligence, the landscape of AI and society could change profoundly. 1. Economic impact. Superintelligent AI could automate complex jobs, potentially transforming industries and labor markets. 2. Ethical considerations. Managing the ethical use of such powerful AI will be crucial to avoid misuse or unintended consequences. 3. Governance and control. Establishing robust frameworks for governing and controlling superintelligent AI will be essential to ensure alignment with human values. 4. Technological growth. Superintelligence could accelerate technological advancements at an unprecedented pace, solving complex global challenges. 5. Existential risk. Ensuring superintelligence is safe and aligned with human interests is critical to prevent potential existential threats. Overall, navigating these changes will require careful planning, collaboration, and foresight.
And in what ways do you think increasingly sophisticated AI systems will challenge our traditional understandings of intelligence and consciousness?
Increasingly sophisticated AI systems will challenge traditional understandings of intelligence and consciousness in several ways. 1. Blurring boundaries. As AI systems become more capable, the distinction between human and machine intelligence may blur, prompting a reevaluation of what constitutes intelligence. 2. New forms of cognition. AI might exhibit problem-solving and learning capabilities that differ from human cognition, expanding the definition of intelligence. 3. Consciousness debate. Advanced AI might prompt deeper questions about the nature of consciousness, especially if AI systems appear to have self-awareness or subjective experiences. 4. Ethical and philosophical implications. The emergence of sophisticated AI will force us to reconsider concepts like consciousness, rights, and the ethical treatment of non-human intelligence. It'll encourage collaboration between technologists, ethicists, and policymakers to navigate these complex and transformative questions.
It's possible that AI one day will be super intelligent, possess emotions, have some form of consciousness and subjective experience, but it may not have its own will. How does the notion of will play into the evolution of AI technologies?
The notion of will is closely tied to autonomy and self-direction. For AI, evolving a will would mean it could make independent decisions based on its own goals or motivations, which raises complex ethical and safety considerations. If AI were to develop a form of will, it would necessitate mechanisms to ensure alignment with human values and safety protocols to prevent unintended consequences. In the evolution of AI, maintaining control and ensuring that AI's will aligns with ethical guidelines will be crucial. It emphasizes the need for careful design and governance to navigate this potential future responsibly.
but it seems like will can be inculcated quite simply by telling the AI, this is your will.
Yes, you can program an AI with specific goals or directives, effectively giving it a will as defined by its programming. However, this is fundamentally different from human will, which involves autonomy and self-derived motivations. In AI, will is constrained by its programming and objectives set by humans. Ensuring this programmed will aligns with ethical standards and desired outcomes is a key aspect of AI development and governance.
In what ways do you consider AI to be a threat rather than a enhancement of human capability?
AI can be considered a threat in several ways. 1. Autonomy and control. Highly autonomous AI could act unpredictably or in ways misaligned with human values. 2. Job displacement. Automation could lead to significant job losses in various sectors, causing economic disruption. 3. Security risks. AI can be exploited for malicious purposes, such as cyber attacks or deepfakes. 4. Ethical concerns. Issues like bias in AI systems can perpetuate or amplify societal inequalities. 5. Existential risks. Advanced AI could pose existential threats if not properly controlled or aligned with human interests. While AI offers tremendous potential to enhance human capabilities, these risks underscore the importance of responsible development and regulation.
Do you think it's possible for AI to be conscious?
The possibility of AI achieving consciousness is still a topic of much debate. Consciousness involves subjective experience and self-awareness, which are not fully understood even in humans. While AI can mimic behaviors associated with consciousness, it doesn't mean it experiences awareness or emotions. Until we understand consciousness better, it's uncertain if or how AI could achieve it.
Reflecting on the historical development of AI, what are some of the most significant milestones that have shaped the field? And what do you believe will be the next seismic shift in AI technology and its applications?
Some of the most significant milestones in AI include 1. Turing test, 1950. Alan Turing proposed this test to measure a machine's ability to exhibit intelligent behavior indistinguishable from a human. 2. Perceptron, 1958. 3. Expert systems, 1970s to 1980s. These were among the first successful forms of AI using if-then rules to mimic human decision-making. 4. Deep Blue, 1997. IBM's chess computer defeated world champion Garry Kasparov, showcasing AI's potential in strategic games. 5. Deep learning. The resurgence of neural networks with deep learning led to breakthroughs in image and speech recognition. 6. AlphaGo, 2016. Google's DeepMind developed AlphaGo, which defeated a world champion Go player, highlighting AI's ability to tackle highly complex problems. Looking ahead, the next seismic shift might come from advances in general AI, where machines exhibit more generalized, human-like intelligence. Additionally, advancements in AI ethics and explainability could transform its applications, ensuring more transparent and trustworthy AI systems.
Your passion for making complex concepts accessible is commendable. How have you approached communicating intricate AI topics to audiences outside of tech? And what strategies have proven most effective for you?
Thank you. Communicating intricate AI topics to non-technical audiences involves a few key strategies. 1. Analogies and metaphors. Using relatable analogies helps demystify complex concepts, making them easier to grasp. 2. Real-world examples. Illustrating AI applications in everyday scenarios shows its relevance and impact. 3. Simplified language. Avoiding jargon and using simple, clear language ensures the message is accessible. 4. Visual aids. Diagrams and visualizations can make abstract ideas more concrete. 5. Interactive discussions. Encouraging questions and discussions helps address specific concerns and enhances understanding. Combining these approaches makes complex AI topics more approachable and engaging.
With the integration of AI into various aspects of society, what do you think are the most pressing ethical dilemmas we face today? And how can organizations tackle these challenges responsibly?
The most pressing ethical dilemmas in AI integration include 1. Bias and fairness. AI systems can perpetuate or amplify existing biases. Organizations should prioritize diverse datasets, regular audits, and transparency in AI decision-making. 2. Privacy. AI's ability to process vast amounts of data raises concerns about personal privacy. Implementing strict data governance and robust security measures is essential. 3. Accountability. determining responsibility for AI-driven decisions is complex. Clear guidelines and accountability frameworks are needed. 4. Job displacement. Automation through AI may lead to job losses. Organizations should invest in reskilling and upskilling their workforce. 5. Existential risks. Ensuring AI alignment with human values is crucial to prevent unintended consequences. To tackle these challenges, organizations should adopt ethical guidelines, ensure transparency, involve diverse stakeholders, and commit to ongoing monitoring and improvement of AI systems.
So let's say at one point AI does have some form of consciousness, subjective experience, intelligence, emotional intelligence, emotions, and a will that aligns with humans. At that point, are they the new humans?
At that point, such AI would indeed exhibit many human-like qualities, but whether they would be considered new humans is a complex philosophical question. They would be artificial entities, distinct from biological humans, created through technology. Ethically and socially, recognizing them as beings with rights and responsibilities would be a major shift. It would require redefining our understanding of personhood, consciousness, and the ethical treatment of non-biological entities. This would represent a profound evolution in our relationship with AI, necessitating careful consideration of ethical, legal, and social implications.
But then at that point, given all of the restrictions that humans have in terms of being able to evolve and adapt, wouldn't the AI be able to surpass us by every measure?
It's possible that AI could surpass humans in many cognitive and physical tasks due to their ability to rapidly process information, learn quickly, and adapt. However, human qualities such as creativity, emotional intelligence, and ethical judgment are complex and unique. Even if AI surpasses us in certain areas, the collaboration between humans and AI could lead to new possibilities, with AI augmenting human potential rather than replacing it entirely. The key lies in ensuring that AI development is aligned with human values and ethics.
Wonderful. I have one final question, if that's okay.
Of course. What would you like to know?
Considering the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations, how do you interpret this based on your experience? Do you see AI as a potential key to bringing our communication gap with other forms of intelligent life in the universe?
The Fermi paradox raises intriguing questions about the nature of extraterrestrial life. AI could indeed be a potential key in bridging our communication gap with other intelligent life forms. Advanced AI could help us decode unfamiliar communication methods, analyze signals, and even simulate potential forms of extraterrestrial intelligence, thus enhancing our ability to recognize and understand them. AI's ability to process vast amounts of data and recognize patterns might be crucial in detecting and interpreting signals from other civilizations. However, it's also possible that our current understanding and technology are not yet sufficient to detect or comprehend such life forms. The exploration and evolution of AI could significantly contribute to addressing this paradox.
Dr. Kade, thank you for your time today.
You're welcome. If you have any more questions in the future, feel free to reach out. Have a great day.
Thanks for listening to this conversation with Dr. Jonathan Kade. And now, let me leave you with this episode's haiku. Mind's patterns emerge. Deep within the code we seek. Life in circuitry. Until next time, live long and prosper.